Hello, my dear students. Welcome to my YouTube channel. So, this is the second video of Karnataka CET NEET 2021 of level 2 for the solid state. So, in the previous video, we discussed some of the very easy questions of a solid state, where just by if you know the basic information about the topic, then you can answer such questions very easily. So here this is a level 2 where you had to apply, or you had to if you have worked a little bit more in that particular topic, then you can answer it very easily. Yes. So the first question is, the coordination number of a metal crystallizing in a HCP structure is. So we know that coordination number. What exactly the coordination number? See, in case of a crystalline solids where there is a regular arrangement of a particles, okay, the atoms are in touch with each other, or the atoms are in contact with each other. So for a particular atom, so it is in touch with how many atoms? Okay, that is nothing but a coordination number. So when it comes to HCP, as we all know, HCP is a hexagonal close packing structure. Okay, in case of a HCP, you have to concentrate. HCP can be discussed in a different close packing. One is HCP can be done in a two-dimensional close packing, where HCP can be done in a three-dimensional close packing. So when it comes to the two-dimensional HCP, the coordination number is 6. Okay, where the three-dimensional HCP, the coordination number will be 12. Okay, so the answer for this question is 12, and there is a chance of getting such type of questions that for the HCP, if it is 12, for the FCC, we might be knowing FCC face centered cubic lattice. Okay, its coordination number is also 12, and for a BCC it is 8. So you have to remember all the coordination number, then you can answer if such question will come. Next question is, a molecule contains atoms X and Y, so that X occurs at the corners of the cube while Y at the face center. So the formula of the molecule can be. So in order to answer such type of questions, we should know the contribution of each constituent particles to that particular unit cell. See, when I say a corner atom, the number of atoms is how much? Total number of atoms we could say, or the rank of that unit cell is 1, and the contribution is how much, dear students? It is 1 by 8. Similarly, the atom which is at the center, that is of BCC, so total number of atoms is 2, and the contribution of the center atom is like no contribution. The center atom will not contribute with any other unit cell. When it comes to FCC, the rank of the unit cell is 4, and the contribution of atoms which are at the center of a face is 1 by 2. Okay, so here what they are asking, a molecule contains atoms X and Y. So we have a X and Y atom where X occurs at the corner. So X atoms is at the corners. Okay, so 8 atoms, and at the 8 corners, obviously, so it is contribution is like 1 we will going to consider. Means like 8 atoms, and each atom at the corner means 8 will get cancelled, going to get 1. So again what they are telling, Y at the face center. Okay, so Y at the face center means how many we have? 6 atoms, okay, at each faces, and the contribution of the face center atom is how much? Half, that is 6 divided by 2, 3. So X equal to 1, Y equal to 3. So X is to Y, 1 is to 3, that is X is 1, Y is 3. Okay, so the answer for this question is option A. So if you know the basic of a contribution of each atom, then you can answer such type of a question. So now the third one, which of the following metal oxides is antiferromagnetic in nature? So which of the following metal oxides is antiferromagnetic? See, this part of the topic is deleted for this academic year. But still, if you know the basic, then you can answer it. Okay, so that's why I have included this question, so no problem. So here, which of the following metal oxides is anti-ferromagnetic in nature? So the answer for this question is Mn2. Okay, so manganese dioxide is an example for the anti-ferromagnetic substance, whereas titanium oxide is ferromagnetic in nature, and the vanadium pentoxide is paramagnetic in nature, and the chromium oxide is ferromagnetic in nature. Okay, so I have given the explanation, like the answer for all the four, but for this question, anti-ferromagnetic in nature is manganese dioxide. Okay, so the next one is the fraction of a total volume occupied by the atoms in a simple cube is. So dear students, it's one of like a important question. Such type of questions will definitely appear. See, the fraction of a total volume occupied by the atoms in a simple cube. Okay, so for a simple cube, when you go for the derivation of packing efficiency, we're going to get a value called pi by 6. If you know the derivation, then you can say. So the simple cubic unit cell, the fraction of a total volume occupied is pi by 6. So the answer for this question is pi by 6, option B. Similarly, you should know for the BCC and you should know for the FCC. So for a BCC, the answer is, if I am not wrong, it is pi root 3 by 8. Pi root 3 by 8. Whereas for the FCC, we will going to have pi 3 root 2. Pi by 3 root 2, and here for a BCC and here for the FCC. So all the three values you should know, so that if they change the question and if they ask you for BCC over here, you have to answer this one. If they ask for the FCC, then it is pi by 3 root 2. So these are the answer for the fraction of total molecules. So the next question, in which pair most efficient packing efficiency is present? So it's a very simple question. If you know the derivations of packing efficiency, so for the simple we're going to have 52 around something, and for the BCC we're going to have 68 point something, where for the FCC we will going to have 74%. That percent indicates what? How much total volume is occupied in that particular unit cell. So more efficient packing, more closely packing is done where the percentage of packing efficiency will be more. So we know that HCP, which also have the same packing efficiency, that is 74%, and CCP, where it is nothing but the FCC, it also has got a 74%. So the answer is option B. Which of the following represents, next question, which of the following represents correct order of a conductivity in solids? Okay, so this K represents what? K is nothing but the kappa, or conductivity, or specific conductance we can say. Okay, so which of the following represents the correct order of a conductivity means, see, we all know that metals are the very good conductor, okay, followed by the semiconductor, then insulator. So metals are the pure conductors, semiconductors are partially conducting in nature, where the insulators are not conductors. So according to the arrangement, K represents what? It's a conductivity. So conductivity of a metals is always more than the insulator, yes, okay, and the conductivity of an insulator is very less than a conductivity of a semiconductor. So this arrangement is correct according to the question that they have asked. So option A is the correct one. So the last question, that the number of tetrahedral voids per unit cell in NaCl crystal is. Okay, so for this you should know the basic thing. So whenever we take any crystal system, the tetrahedral voids will be twice the number of atoms. So this formula you have to remember. So whenever we take any crystal system, whatever the total number of atoms are there for that particular unit cell, its tetrahedral void will be double of that one. So for example, if I take simple unit cell, so for a simple unit cell, the rank of that unit cell or the number of atoms at unit cell is 1. So if I say for a tetrahedral void, it is 2 into 1, that is twice. Okay, so here I am taking a simple unit cell. Actually you have to go with the FCC and the VCC. Okay, so this is what the formula. Similarly, octahedral void will be how much? It is same as that, the number of atoms. Okay, so this formula you have to remember. Now according to the question, they are asking for the sodium chloride crystal. So sodium chloride is actually a FCC crystal. So in FCC, what is the number of atoms? It is 4. Okay, and what might be the tetrahedral, what they are asking? Yes, they are asking for the tetrahedral void. So tetrahedral void is how much? As we learned, it is twice the number of atoms. So 2 into 4, so tetrahedral is 8, whereas octahedral is how much? It is equal to the number of atoms, so it is 4. So according to this, option B is the correct one. Okay, and even what else? 4, and they are asking for the tetrahedral void, means it is only 8. And next option C, if you go through, twice the number of octahedral void. Yes, so this is also an option. So tetrahedral void is how much? It is twice the number of octahedral void. Yes, octahedral void is 4 and the twice of that one is a tetrahedral void. So for this question we have option B, option C as the answer. Okay, so this is about the solid state chapter wise question for your competitive exam of level 2. So in our next video we'll go through some of like a application question, so that you can apply some formulas over there and you can solve the questions. I hope you find this video useful. Thank you.